Sometime in the future, we're going to see the following derivative rule, but I want to mention it now just so we can see an example of how derivatives play out in practice. The derivative of the square root of x is 1 divided by 2 times the square root of x. You might already believe this if you believe the power rule. Right? The derivative of x to the n is n times x to the n minus 1. So if n is 1/2, then I've got that the derivative of x to the n, now 1/2, is n, 1/2, times x to the n minus 1. And conveniently, 1/2 minus 1 is negative 1/2. This is really the same as this. It's just written here with the square root symbol instead of with the exponents. We can use this derivative rule to help explain certain numerological coincidences. Let's take a look. Look, the square root of 9,999 is 99.9949998. Okay, so it keeps on going forever. It's irrational. But this is bizarrely close to 99.99. Instead of 499, I'm just saying it's close to 99.995. Is this just a coincidence? This isn't a coincidence. Look, the square root of 10,000 is 100 because 100 squared is 10,000. What I'm really doing here is wiggling the input. I'm going from 10,000 to 9,999. In other words, I'm trying to calculate the square root of 10,000 minus 1. Wiggling the input down a bit. What does the derivative calculate? Well, the derivative calculates the ratio between output change to input change. So the square root of 10,000 wiggled down a little bit is about the square root of 10,000 minus how much I change the input by times the ratio of how much I expect the output change compared to the input change. Now we can try to calculate the derivative at 10,000. What's the derivative at 10,000? Well, it's 1 over 2 times the square root of 10,000. The square root of 10,000 is 100, so it's 1 over 2 times 100. 1 over 2 times 100 is 1 over 200, which is 0.005. Look, the square root of 9,999 is so close to 99.995 because the square root of 10,000 is 100, and when I shift the input down by 1, this derivative calculation is suggesting that the output should be shifted down by about 0.005, and indeed it is. This is a great example of calculus. Yes, you could have asked your calculator to compute the square root of 9,999. But you couldn't have asked your calculator to tell you why. Why is that answer so mysteriously close to 99.995? In short, calculus is more than calculating. It's not about answers. It's about reasons. It's about explanations. It's about the stories that human beings can tell to each other about why that number and not another. Now, that's not to say that the numbers aren't fun to play with themselves. And we can use this same trick to do other amazing feats, like we can try to estimate the square root of 82. I know the square root of 81 is 9. I'm trying to say something with the square root of 82. So I'm trying to wiggle the input up a little bit. Well, derivatives have something to say about that. The square root of 81 plus 1, right, the square root of 82, would be about the square root of 81, which is 9, plus how much I expect the output to change. Right? I wiggled the input. I expect the output to change by some amount. Well, the derivative is measuring how much I expect the output to change by. So I'm going to take the derivative of this function at 81, of the square root function at 81. I'm going to multiply by how much I'm wiggling the input by. This will be how much I expect the output to change when I change the input. Now, in this specific case, what's the derivative at 81? Well, that's 1 over 2 times the square root of 81, which is 1 over 2 times 9. The square root of 81 is 9, which is 1/18. So I would expect the square root of 82 to be about 9 plus 1/18, because I expect wiggling the input up to wiggle the output up by about 1/18. And this is pretty good. There's actually 2 different ways to tell that this isn't such a bad guess. Here's one way to tell. What's 1/18? Well, it's 0.05 repeating. And what's the actual value of the square root of 82? It's 9.055. Look, it's pretty close to 9 plus this. So that's pretty good. Another way to see that this isn't such a bad guess is just to take 9 plus 1/18 and square it. When I square 9 plus 1/18, I get 9 squared plus 2 times 9/18 plus 1 over 18 squared. 2 times 1/2 is 1. This is 81 plus 1 is 82. And 1 over 18 squared is the very small number 1 over 324. So either way you look at it, we're doing pretty good to guess that the square root of 82 is about this. And we're doing it with derivatives. Again, it's derivatives for the win. By relating the input change to the output change, we're able to estimate the values of functions that would be very hard to access directly.